Okay, let's take a look at normal probability distributions on in Google Sheets. And this is our first chart, finding probability. And this is where you're given the mean, you're given the standard deviation, and then it's asking you something. Well, let's look at an example of what I mean. Okay. So I tell you mean, let's say it's 30, standard deviation is 2, and we're trying to find the probability that x is greater than 31.5. We're going to look at all the different cases. Well, it doesn't matter whether it's greater than or equal to, same formula. And the number that follows your inequality is your A. So here, A is equal to 31.5. If I can make that a little bit bigger so you can see it. There you go. So then we're going to plug into this formula, equals 1 minus norm.dist. Beginning parentheses, and then we're going to put in A, then our mean, and then our standard deviation, and then true. So 31.5, comma, the mean, which is 30, comma, standard deviation, which is 2, and comma, true. Close parentheses, and press enter. That would be our answer. Now let's say we want to find the probability that x is less than or equal to 28. Now that's this first form, less than or equal to. And again, whatever number follows your inequality is your A. So A is equal to 28. This tells us to use this formula. Equals norm.dist. A, mean, standard deviation, true. So A was 28, comma, mean, 30, comma, 2, comma, true. And then press enter. And that'd be our answer. Let's say we're trying to find a probability that it's between 27.3 and 30.8. That's our last type. And again, notice these are less than or equal to's, and I put less than. I wanted to really emphasize it does not matter what your symbol is. So A is what's first, and B is what's second. So A is your smaller number. So A is 27.3, and B is equal to 30.8. Okay, equals norm.dist, B, mean, SD, true. So equals, try it again, equals norm.dist. Hey, how big that window is, it pops up. B, can I get that to go away? Yeah, I can. B is 30.8, comma, mean, which is 30, comma, standard deviation is true, or 2, and then true, minus, I'm just plugging in the values over here. Norm.dist, and I think this is A. Yeah, A, mean, standard deviation, true. A was 27.3, comma, 30, comma, 2, comma, true. So again, just plug in our A and our B and our mean and our standard deviation. And that would be your answer. Now this is done when it's asking you to find a probability or percentage, proportion, or area. Now if it says standard normal in a problem, that tells you automatically the mean is 0 and standard deviation is 1. So if you're working a problem and you're looking, you say, well, I don't see mean and standard deviation. It's probably because it's standard normal. Get a raise. Excuse me, sneeze. Now, if we're trying to find the values, let's take a look at some examples of that. Okay, so mean is still 30. Standard deviation is true. And we're trying to find a value that separates the top 10%. Now, I don't have my tablet with me, so I can't really draw. But if you draw a bell curve, top 10% means you got 10% in your right tail. If you got 10% in your right tail, you got 90% in your body. This norm.inv is based upon the area to the left. Maybe I can draw with the mouse. That might work. They look pretty. Okay. So if we say that's 10% there, then this has to be 90% because it all has to add up to 100%. Should be a decimal there. This is in decimal form. And this is the value we're trying to find. The value separates the top 10% from the rest. And our formula, our function, is based upon the area to the left. So we're trying to find this value right here. So the area to the left of it is 0.90. So we'll go equals norm.inv probability, which is area to the left, so 0.90, comma, our mean and a standard deviation, 30 and 2. And that'd be our answer. These are kind of challenging problems because the wording can really throw you off. Where they talk about the area in the right tail, area in the left tail, area in the middle. Let's look at find a value that separates the bottom. Now I'm making it pretty simple when I say top and bottom. And bottom 5% implies that the 5% is over here. Boy, that's bad. I can't draw with this mouse. If that's 5%, this has to be 95%, because it all has to add up to 100%. Now we're trying to find this value right here, which is this line, and we look at the area to the left, which is 0.05. So I'm going to do equals norm.inv 0.05, comma our mean, which is 30, comma our standard deviation, which is 2. And that would be our value. And one last one of that. Find values that separate the middle 90%. This type, they're telling us the value in the middle is 90%. Now all of it adds up to 100%, and these are symmetric. So we're going to take the remaining 10% and split it into our tails. So this will be 0.05. And this one will be 0.05. Now we're trying to find this value, and we're trying to find this value. Now first this one. So the area to the left would be 0.05. So we do equals norm.inv 0.05, comma mean 30, comma standard deviation, which is 2, and press enter. And we get that. And again, this is just still based upon this one right here. And our other one, let's get back there. We're trying to find this one. we want the area of the left. Specifically, we want all the area of the left. So we have to add these two together. 0.05 plus 0.90 is 0.95. So equals norm.inv 0.95, comma, mean, which is 30, comma, standard deviation, which is 2. This would say that 90% of our data falls between these two values. Okay. The other type that you'd run across, these are the main ones for the normal distribution, is ones involving the central limit there. This is where you're looking at sample mean instead of like a individual x value. So we're finding a probability, and I don't have it written right. This should be x bar. I'm not sure why I didn't put a bar over it. But we're looking at probability the sample mean is less than a value, greater than a value, or between two values. Specifically, we have our mean or standard deviation again, but now we have n. N is the amount in our sample. Like we say we took a sample of 15 golfers, and we're finding a probability that the sample mean is less than 10. So if I come down here, let's say my mean is 90, standard deviation is 5, and I talk to, let's say 50 individuals. And I won't do all of these because I think you'll have an idea. But here we're looking at the probability that the sample mean is greater than, let's say, 88.1. Maybe I will do it. It won't be that long. So I'll do this one. So that equals, did I do that one right? I don't think I put a 1 minus, did I? I don't remember doing that anyway. Oh, I did. Never mind. It's been a long day. Okay. Back to this. This is a greater than. That's this one. So we want to use this formula. Equals 1 minus norm dot dist. A was 88.1. That's the number that falls or inequality. Comma. Mean is 90, comma, standard deviation, which is 5, divided by the square root of 50. That is the SD divided by square root of n, and then comma true. And that'd be our answer. Let's say I'm trying to find a probability that x bar is less than or equal to 90.1. So A would equal 90.1. Even though I said it, let me write it. Up here, A was at 88 or 88.1. So less than or equal to this formula. So we're going to do our first one here. So equals norm.dist A. Norm.dist A, which is 90.1, comma mean, which is 90, comma standard deviation, which is 5, divided by the square root of n, which is 50, and true. Did I put everything right here? 90, okay. And then our last example. Let's see. 88 to 91. When you got a range, your smaller one is your A, so A is 88, B is 91, and I'm not sure why I put that there. That should be a parentheses. And the between case is this third one, and this is our formula. We just plug in the values we identified. So it equals norm.dist B, which is 91, comma mean, which is 90, comma standard deviation, which is 5, divided by the square root of n, which is 50, comma true, close parentheses. That's the first line, and then minus norm.dist A. What was A? 88, comma 90, our mean, comma, standard deviation, which is 5, divided by the square root of 50, comma, true. Looks complex, but I'm just plugging in A, B, mean, standard deviation, and N. Other than that, it's exactly as what you see right here. Now I won't go through these cases, but you can have ones where you find the value. The difference is here, see this is probability mean standard deviation divided by square root of n. Probability mean standard deviation. So the only thing that's different is you take your standard deviation and divide by square root of n. And you may have noticed that's the only thing we did different actually in these problems right here. And that's how you use Google Sheets to work with normal distributions.